We're now going to talk about the second type of reactions that alkyl halides can undergo, and that's the elimination reaction. Here's the overall reaction for an elimination involving an alkyl halide. So notice that you start, of course, with the alkyl halide, and this time you're treating it with a base. You form an alkene product in addition to the halide leaving group and a protonated base. Notice that during the course of this reaction, 2 sigma bonds are broken and 1 pi bond and 1 sigma bond are formed. Since during this reaction, an equivalent of halogen and hydrogen leave during the reaction in terms of from the organic product, this is called a dehydrohalogenation reaction. We use lowercase Greek letters to designate different carbons in an elimination reaction like this. And the carbon with the leaving group, in this case the halogen, is going to be called the alpha carbon. And then as you go out, you go through the alphabet. So 1 carbon over is going to be the beta carbon. If we had another carbon here, that would be called the gamma carbon, and so on. The proton on the beta carbon is called the beta proton. And since it is this proton that's lost during dehydrohalogenation, we say that this type of reaction is an example of a beta elimination reaction. Also, note that the pKa of a proton on an sp3 carbon like this one here is typically around 50. So this is not an acidic proton. So since this proton is not particularly acidic, we have to wonder what drives this reaction to go. Why is this base ultimately going to be able to deprotonate this proton? And one of the reasons for that is that the 2 sigma bonds that are going to be broken are going to be replaced with 1 carbon-carbon bond. Of course, you also have this new sigma bond over here, but this carbon-carbon bond is very stable, so this is going to be favorable in terms of the delta H of the reaction. Additionally, if we look at what we're starting with and what we're ending with, we start off with 2 entities. So we start off with a base and an alkyl halide, and we end up with 3 entities. So we make an alkene, we kick off a leaving group, and we also have a protonated base at the end. So in terms of the delta S of the reaction, this is also favorable. Let's take a look at the possible ways that this reaction could run. And we're only going to really investigate 2 possibilities here. There are others that are possible, but it's beyond the scope of this course to take a look at those. So one of the reactions that we will look at is a 2-step process. And so this would be where the leaving group comes off in the first step. And then in a second step, the base removes the beta proton and yields the alkene product. The second possibility that we will look at is the concerted 1-step mechanism where everything's happening simultaneously. So the base is deprotonating at the same time the alkene's forming and the leaving group is being displaced all at the same time.